Hello, welcome back to Algebra 1 with Miss Betsy. Today we're going to be learning how to solve quadratic equations by using the quadratic formula. The text that I'm using today looks like this. It's Algebra 1 for Christian Schools, published by Bob Jones University Press. I'm using the second edition, and this is not going to be a rigorous definition or a proof of how you arrive at the quadratic formula, because I'm making this video specifically just to show how kids or other students can actually use the quadratic formula. At some other point, I'll go through the process of where you derive the quadratic formula by completing the square on the standard form of a quadratic equation, but what I'm going to do today is simply show you how to use the quadratic equation. So let's go ahead and pray. I'll have a lame joke for you and we'll get started. God, thank you for who you are. Thank you that you are an ever-present constant in our life, just like we have constants in the world of mathematics. Lord, you are constant in our life, and we are so thankful for that. Help us to learn the things you'd have us learn to do, and help me to communicate clearly. And I pray in the name of your Son, Jesus. Amen. Okay, well, I promptly forgot the joke that I was going to tell you, and let's see if I can even remember what it was about. I think it was not about an animal. Okay, this is a lame one. This came out of a kid's joke book that I saw a while ago. It says, if you take a brown rock and you throw it into the Red Sea, what do you get? You get a wet rock. No, it's not a purple rock, you get a wet rock. And I can just see some of you rolling your eyes at me on that one. Okay, we're on page 470 if you're using the second edition of Bob Jones University Press. Okay, I've got my notes here. Now we've learned that quadratic equations are second degree equations. And we learned that we have the standard form of a quadratic equation, and it looks like this. ax squared plus bx plus c is equal to 0. Sometimes I call that the general form. We have everything on the left-hand side of the equation set equal to 0. Now, if we had wanted to go ahead and solve for x, just with this general algebraic equation here, we could do that by using the method of completing the square. Probably for next year I will go ahead and make a video that shows that derivation, but you have to just follow all the steps to complete the square. And if you were to do this, this is what you would end up with. You would have that x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2a. And you look at that and you might think initially, what in the world do I want to do with that mess there? That is really, really a horrible mess. Well, what we have here is a way that you can solve an equation that can't be factored, that you can't use the zero product property on. Obviously, if it can't be factored, you cannot use the zero product property on it. You cannot solve it by taking the square roots of both sides of the equation, and you really don't want to mess with completing the square. You simply use the quadratic formula. Well, how in the world am I going to do that? Well, let me just show you. Before I go back to that, I want you to notice, when I wrote this, I said this is not negative b. This is the opposite of b, plus or minus the square root. Now the plus or minus is giving us two answers, isn't it? And why is it that we have two answers? Well, we have two answers because there is always a positive and a negative square root. Okay, so we have two answers that are possible here. Now, let's go ahead and look at example number 1 in your text. And they're asking you to solve this by using the quadratic formula. Let me go ahead and write the problem. X squared minus 5x minus 6 is equal to 0. X squared minus 5x minus 6 is equal to 0. Now if you look at that, and by now you should be very comfortable and very accomplished in solving equations by factoring, you look at this and you say, why in the world would I want to use a quadratic formula? I can factor this. So yes, let's go ahead and factor this. And we end up with x minus 6 times x plus 1 is equal to 0. We apply our zero product property, and we have as our solution set two possible solutions. We have a -1 and we have a +6. So this is an example where you definitely want to look at that, and when you're given a choice, you're going to say, oh, that's a simple one to factor, and the solutions are -1 or +6. We're going to go ahead and use the quadratic formula because this is an excellent one to teach on. So what do we want to do first if we want to solve an equation using the quadratic formula? Well, write your quadratic formula. And that tells us that x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, and all of that is over 2a. You need to memorize the quadratic formula. You're not going to have your cheat sheet available. You need to memorize it. What's the best way to memorize a bunch of letters and symbols? Write that formula down every single time you do a problem, and it will become very much second nature to you. So we're going to solve x squared minus 5x plus 6, minus 6 is equal to 0 using the quadratic formula. All we have to do is substitute in our values for a, b, and c. It's going to be beneficial to you to, especially as you're learning how to do this, to write out that a is equal to 1, b is equal to -5, and c is equal to -6. Obviously, a, b, and c are not always 1, -5, and +6. We got these from the coefficients. The leading coefficient, or the coefficient of the squared term, is a. The coefficient of the first degree variable is b, and notice that it includes that sign. And c is your constant term. Now that we know for certain what the values of a, b, and c are, we are going to substitute these in to the equation. And we have x is equal to the opposite of, not a 1 because we're doing b, opposite of a -5 plus or minus the square root of a -5 squared minus 4 times a, which is 1, times c, which is a -6. Make sure a radical symbol extends the whole way over everything that's the entire way over the radicand. Now all of this is going to be divided by 2 times a, or 2 times 1. Now I want to pause for a moment and have you look and see how I have substituted everything in. Use your parentheses. You hear me say this time and again, over and over. When you are substituting, indicate your substitution with parentheses. It will help you to keep track of your negative signs, and it will lessen the number of arithmetic errors that you have. Arithmetic is how you pronounce arithmetic when you're using it as an adjective. There's your English lesson for the day. Now, x is equal to opposite of -5 is a 5, plus or minus the square root of 25 minus a -24. 25 plus 24 divided by 2. X is equal to 5 plus or minus the square root of 49 over 2, and then you just continue solving this plus or minus, plus or minus 7 divided by 2. So x is either going to be 5 minus 7, which is a -2, divided by 2, which is a -1. Or it's 5 plus 7, which is 12, divided by 2 is 6. And this, of course, is the solution that we were looking for because this problem right here was one that was very simple to solve by factoring. We have the same answer, two vastly different ways, hugely different ways to solve it, but this gives you an introduction to the quadratic formula and shows you that you just follow carefully with your algebra the whole way through it and you end up with the correct solution. Why is the quadratic formula important? Because most of the time you're not going to be able to factor a quadratic equation as you move on in math. Most of the time you're not going to be able to solve it by taking the square root of both sides of the equation. And typically you don't want to solve it by completing the square because it's just an extra large amount of work. So this was example 1. Let's go ahead on to example 2 and see what we end up with. Now I am not going to erase my quadratic formula because there's really no reason for me to continue writing it out for you because I know it. But when you guys are doing your problems, write your quadratic formula every single time. See, now we're going to do example number 2, and I must have skipped a page. Okay. Example number 2, we have 3x squared plus 4x minus 8 is 0. 3x squared plus 4x minus 8 is equal to 0. And again, we have an equation here, or for the first time, we have an equation that is not factorable, and you can't solve it by using the square root property. So we're going to go, and who wants to complete the square? It's extra work. So let's go ahead and use the quadratic formula. A is equal to 3, B is equal to 4, and C is equal to a negative 8. I've already written my quadratic formula. X is the opposite of B plus or minus the square root of B squared minus 4AC, all of that over 2A. See, it sounds quite impressive, or else just makes your eyes glaze over. The more you work on this, the more it will become second nature to you, and you will have no difficulty. Anytime I ask you to give me the quadratic formula, you'll have it in your mind. We're going to substitute in x is equal to the opposite of 4 plus or minus the square root of b squared, which would be 4 squared minus 4 times a, which is 3, times c, which is a negative 8. All of that divided by 2 times a, which is 2 times 3. X is equal to the opposite of 4, or negative 4 here, plus or minus the square root of 16 plus, we have negative times negative is positive. 4 times 3 is 12. 8 times 12 is 96. All of this divided by 6. X is equal to negative 4 plus or minus the square root of 112 divided by 6. Now, is that the answer? No. We have common factors for one thing. But is 112 a perfect square? No. 144 is. 121 is. 100 is. But 112 is not a perfect square, but there are perfect squares underneath that radical, so we need to simplify it. Make sure that you don't forget to simplify underneath your radical sign. I was only going to substitute in with the brown. I kept right on working the problem. I'm looking at this, and I know that this is divisible by 12 because the last two digits, which are 12, are divisible by 4. I misspoke. This is not divisible by 12, this is divisible by 4 because 12 is divisible by 4. So I'm going to factor 112. I'm going to say that we have 4 times 28. 4 times 28 is 112. 4 times 7 is 28. Right here I have a perfect square times 7. So I'm going to rewrite this as x is equal to -4 plus or minus the square root of 16 times 7 over 6. Now I have perfect square. 16, the square root is 4. So x is equal to -4 plus or minus 4 times the square root of 7, all of this over 6. Now, this is not simplified. -4, 6, and 4 have a common factor of 2. Yes, it should be just fine. This is a more complex form of 2/3 plus 4/3, 5/3, 2/3 plus 5/3. And I can't write a 5. 2/3 plus 5/3, which would be 2 plus 5 over 3. I'm not going to go through showing you how to separate these into two fractions, but what you're going to end up with is x is equal to -2 plus or minus 2 times the square root of 7 over 3. Okay, my co-op kids, if you had me in class, right now I'd be saying, okay, explain to me what I did. If you do not see what I did here, send me a text, because this is important that you understand what's going on. Now we have our solution, because there are no more common factors, and the square root of 7 is an irrational number, so this is as simple as it gets. If they asked you to show the solution to this problem with set builder notation or as a solution set, you would show that as a set that contains the two different elements. Opposite of 2, or -2 plus 2 times the square root of 7 over 3, or -2 minus 2 times the square root of 7 over 3. I, of course, will accept either answer. I'm perfectly fine with an answer that looks like this, unless they specifically tell you to show the solution set. Alright? You can look in your book and make sure you can track what they're doing. You can pause this and repeat. But this is the type of work process that you're going to need to go through to use the quadratic equation. This is the type of answer that you are going to get very, very, very frequently when you solve a quadratic equation by the method of using the quadratic formula. Alright? Let's go ahead and look at one more example. Yeah. And this is recorded in my fancy studio in my dining room, so by the time I get this erased, my family will be done getting ice out of the ice maker. Okay, you done? Okay, one more example. Okay. Example 3. And we have 5x squared plus 3x is equal to 2. We want to solve this equation by using the quadratic formula as well. What we've done before has been set equal to 0. Here we have 5x squared plus 3x is equal to 2. Now, in order to use your quadratic formula, the polynomial must be set equal to 0. Everything has to be on the left-hand side of the equation. Could it be on the right-hand side? Yes, most people aren't going to do it that way. 5x squared plus 3x minus 2 is equal to 0. Now, once again, we're going to identify what our brain freeze. We're going to identify what we're going to substitute. We have that A is equal to 5, B is equal to 3, C is equal to a negative 2. We've written down, or you're writing down on your paper, the quadratic formula. X is equal to the opposite of B plus or minus the square root of B squared minus 4 times A times C. Every bit of that is divided by 2A. So we have X is equal to the opposite of 3 plus or minus the square root of 3 squared minus 4 times 5 times a negative 2. All of this divided by 2 times 5. And then you simply go through the process of finishing up your algebra. X is equal to negative 3 plus or minus the square root of 9. Negative times negative is positive. 9 plus 4 times 5 is 20 times 2 is 40. 9 plus 40. All of this is divided by 10. You can see ahead that we have a perfect square, square root of 49, which is 7. So X is equal to negative 3 plus or minus 7 divided by 10. Now, think back to that problem that we just completed where it was, what was it, negative 2 plus or minus 2 times the square root of 7 over 3 or something. I said it was perfectly fine to leave the plus or minus in the solution. This is not completed because you can simplify this more. There's no radical here. So our choices are X is equal to negative 3 plus 7 over 10, or X is equal to negative 3 minus 7 divided by 10. So X can be equal to 2/5 or minus 1. Make sure that when you're finding these solutions that you take them to the most simple form possible. Negative 3 plus 7 is 4 over 10 reduces to 2/5. Negative 3 minus 7 is a negative 10 divided by 10 gives us a negative 1. So there's another example for you of how you solve quadratic equations by using the quadratic formula. Now I want to review, or just list, I suppose, 4 different ways that you have learned to solve quadratic equations. First, you had something they called the zero product property. And that used the fact that if you have a collection of factors equal to 0, at least one of those factors has to be equal to 0 itself. So you use the zero product property to solve equations that are factorable. X squared plus 3x plus 2 is equal to 0. X plus 2 times x plus 1 is equal to 0. And then you would have the solutions, x is a minus 2 or it's a minus 1. With the zero product property, the polynomial has to be equal to 0. Then we had square roots of both sides. Or I think they called it taking square roots. Taking square roots. In that example, if we started with x squared minus 49 is equal to 0, we had to isolate the second degree term. That's the only thing you want on the left-hand side of the equation. Then you take the square root of both sides of this equation, and you have x is equal to a plus or minus 7. Zero product property, the equation has to be equal to 0. The polynomial is equal to 0. With the method of taking square roots, you have the squared term is equal to everything else. you have completing the square. And what did you have to do for that? Did you have everything set equal to 0 with that method? No. You put your variables on the left-hand side of the equation and your constant term on the right-hand side of the equation. Okay? And then finally we had the quadratic formula. And if we were using the quadratic formula, which I'm abbreviating, you would have your polynomial equal to 0 again. It's essential that you set up your polynomial, that you set up your equation correctly for the method that you are using to solve these quadratic equations. If you're factoring it, it has to be equal to 0. If you're taking roots, the square term has to be isolated. If you're completing the square, variables on one side, constant term on the other side. And finally, if you're using the quadratic formula, the entire polynomial has to be equal to 0. So go ahead and work through those and let me know if you have any difficulties, and I'll see you next time.